Hello everyone, welcome to this lecture. We're talking about periods in the periodic table today. So just to start on some basics, periodic table basics, our columns are called families or groups. So for every column, it is known as a family or group. They all have similar properties because they all have the same number of valence electrons. So we've defined valence electrons before as the electrons in the outermost shell of the atom. Then we also have rows which are called periods. So these periods, all the elements in them have the same number of electron shells. So we'll discuss that a little bit more in this video and how these electron shells look, and then we have a total of 7 periods or 7 rows on the entire periodic table. Just to remember, we've talked about valence electrons before. They are electrons in the outermost shell, which determines a group's ability to bond with one another and really is the focus of all chemistry, or most of the chemistry that occurs within atoms. It happens because of their valence electron. So how many valence electron shells does carbon have? Let's use some of these as an example. So valence shells are in the outermost shell, so we have this nice inner shell first on carbon, which is 2 electrons, and then our outermost shell I am counting 4 electrons. So we have 4 electrons. Now let's look at sodium. We can see our most inner shell has 2 electrons, just like carbon does. And then we have another inner shell of 8. I'm counting 8 electrons. And then our outermost, though, our valence electrons would only be 1 valence electron. And now let's look at aluminum. So aluminum, we can see our first shell has 2, our second shell has 8, and our third shell has 3 valence electrons. So now let's look at the different periods of the periodic table. So our first period is just this top row with only hydrogen and helium. Then we have lithium, the lithium period, which is going across. Second, third, fourth is when we get into our transition metals, our 4th row. And then we have our 6th row is a little interesting because we have our inner transition metals, this extra row down here that gets placed up in here. But for simplicity and to keep everything looking nice and condensed, we just push it down here. But this is technically row 6 still, along with all of this row. And then row 7 is the very bottom. And every row is called a period. So period or row can be used interchangeably. We should be using period. So we really have period 1, period 2, period 3, period 4, period 5, period 6, and period 7. So let's look at the similarities across each period. So each period has the same number of outer valence shell. So that means that for every element in this sodium is in the 3rd period, every element in the 3rd period would have the same amount of inner shell. So we'd have this inner shell of 2 electrons and the second inner shell of 8 electrons. And the only thing that would be changing is its valence shell. It's very outside. So our first shell can have up to 2. Our second shell can have up to 8. Every other inner shell can have up to 18. And then our outside shell every time has up to 8. So this number 18 seems like a lot, and that's because of our transition metals. So as we're looking at xenon, which is a good example, let's go back to our periodic table. It's all the way down here in the 5th period. So each shell actually is at a different energy level. So our inner shell has 2 electrons. It's at a very low energy level. And then our second shell has 8. Our third shell has 18. Our fourth shell has 18. and our fifth shell has 8 because xenon is a noble gas. So xenon's in the far right side of the table. So when we're looking at our table, we know that it goes 2, 8, 2, 8, 18, 18, 8. So let's count our electrons. So we have our 2, then we have our 8 being lithium all the way through neon electrons. So let me backtrack. As we've learned before, each element adds an electron and a proton. So hydrogen has 1 electron, 1 proton. Helium has 2 electrons, 2 protons. So that's how we get our inner shell, is our 2 electrons. Then we have our 8 electrons from this period number 2. So we're adding 8 more. And then we have an 18. But when we look at our table, period 3 only has 8 elements in it, only adds 8 electrons, but each electron shell is really an energy level. So what the interesting thing is, this energy level for period 3 is the same energy level as this group, the first 10 transition metals, this first group from 21 to 30. So what happens is they all go in the same shell. So we'll have electron from sodium, magnesium, cadmium, I think, titanium, wow. All of these, because I can't pronounce our elements, and then we jump back up to aluminum. So that's where our 18 comes from. And then the next time our next shell would be our potassium, calcium, and then jump into our transition metals, which is just 1 row below all of these, and then we'll jump back up to gallium once we're done with our transition metals. So then our final valence shell is still our 8, right? So we have rubidium, strontium, indium, tin, antimony, tellurium, and iodine. And then xenon would make our 8. So it can get a little confusing as we're moving up and down through the transition metals, but the most important thing, and I should have underlined this, is every outside shell can have up to 8. So let's look through elements in the same period. So if they all have the same amount of inner shell, we're looking at oxygen, nitrogen, and carbon right now. So they all have 2 electrons in their inner shell. But for elements in the same period, only the outside valence shell changes as we move through the periodic table. So carbon's actually number 6, nitrogen's number 7, and oxygen's number 8. So we can see that there are 4 valence electrons in carbon, 5 valence electrons in nitrogen, and 6 valence electrons in oxygen. So we are just adding 1 more each time we go down the periodic table, as we're looking carbon here, nitrogen here, oxygen here. So let's practice by drawing these, some of these atoms together. I find it very helpful to try to picture and understand if we can draw these. So if you guys could please draw these in your notebooks. We have hydrogen first. Hydrogen is right here. It has 1 electron. So our first electron is just going to go on the outside, and it'll be the only shell. So we have our nucleus of hydrogen, and then just 1 electron all alone. So if you could pause the video and draw this in your notebooks, that would be awesome. Then we have fluorine. So let's find fluorine on our table. Fluorine is right here. So we have an atomic number of 9. So we're going to have 9 electrons. And we have our first shell of 2 electrons, and then our second shell can have up to 8. So what it would look like is this. We have 2 electrons in our inner shell, and then 7 in our valence shell. We're almost at 8, which is stable. We only have 7, though, for fluorine. So if you could draw this one as well, that would be awesome. Then our final example is bromine. So we have bromine, which like fluorine, but a couple periods down. So bromine is 35. That means we have 35 electrons. Our first shell has 2. Our second shell can have up to 8. And our third shell would have 18, with our outer shell having up to 8. So if you guys don't want to draw this one, that's okay. It's all 35 little electrons, so I understand that can be challenging. But this is really important to understand. We have our 2 electrons in the inner shell. Second shell has 8. Third shell has 18. And then we have 7 in our valence shell. So let's go through a few more examples on how many electrons would each element, I should say, or atom have in their shell. So, wow, that's not how that should work. Give me 1 sec. Sorry about that. I wanted it to just show one thing at a time, so I had to click an extra box. So boron, if we, how many electrons would boron have in its shell? Boron is in row 13 or 3A, I believe. Let's go back to our table here. Boron is in row 13. Yep. So we would have, I would hope you guys can pause the video and think through this, but our answer in the first shell would be 2. And then in the second shell, we would have 3 electrons for a total of 5. Silicon's atomic number is 14. So its first shell would have 2, just like every first shell. Its second shell would have 8. And then I believe it is in I believe it is in the group 14. So it would have 4. Awesome. So let's look at arsenic. Arsenic's first shell, like every first shell, is going to have 2. Its second shell, like every second shell, has up to 8. And its third shell could have up to 18. We have a full 18. And then arsenic has a fourth shell, which has 5 valence. This is its valence shell, so it would have 5 electrons in its valence shell. I hope you guys can understand this. I hope it was clear, really, is what I really hope, that I was able to explain things well. If you have any questions, as always, please let me know. Send me an email, leave a comment in the classroom. Yeah, hope you guys have a great rest of your day.